Hi everybody! This video is going to be specifically over the rhombi and squares. So a rhombus is basically like a square that's been tilted. That's the best way to describe it. But we have the definition here as a rhombus is a parallelogram with four congruent sides. Now its properties are going to be all the same things as parallelograms. So all of those properties of parallelograms, write those on your property sheet for a rhombus. And then the two new properties would be that in a rhombus, diagonals are always perpendicular, which means they form right angles. Okay, and then I'm going to add to that right here. That means that their slopes will be opposite reciprocals. Okay, and then the diagonals bisect a pair of opposite angles. What that basically means is if I have a rhombus here and I draw the diagonals in, then that means that the two angles that are split, okay, those are going to be the same, and then these would be the same. Okay, so it basically cuts each of the angles in half. So just be careful there. The square is the most specific of all of our quadrilaterals that we're going to talk about. A square is a parallelogram with four congruent sides and four right angles. So a square is actually a combination of a rectangle and a rhombus. Remember, the rectangle has the right angles, the rhombus has the congruent sides. So the easiest way to show this visually is with a Venn diagram. So we've got here that our quadrilateral is just a generic four-sided figure. That encompasses all of the ones that we're going to talk about in this unit. Parallelograms are are more specific than just a four-sided figure because they've got some rules, but they're pretty general. Then rectangles and rhombi, or I should say rhombi there, those are going to be still quadrilaterals, but they're also considered parallelograms, and then more specifically squares is the combination of the two. Okay, so the more specific you get, the further into the circles they go. And then trapezoids, which we'll talk about later, they have their own characteristics. So in your square sheet, you need to make sure you write all of the rules for parallelograms, rhombi, and rectangle, because it includes all of those rules. So notice that our shapes just keep building in the amount of rules that they have. So we're just going to jump into some examples. In this one it says that ABCD is a rhombus, and it says to find the value of each measure. So here in part A, if measure of angle BCD is 64, they want you to find the measure of BAC. BCD is this entire angle here, so they just said that's 64. So if I want to find BAC, which is just this angle here, there's a couple rules we have to know. First, we know that in all parallelograms, opposite angles are congruent. Okay, so that means if angle C is 64, so is angle A. So the whole thing there is 64. But for a rhombus, more specifically, we just said that our new rule says that the angles are bisected, which means that they're split in half. So if I know that the whole angle is 64, then that means the measure of angle BAC is going to be half, which would be 32 degrees. So notice not a lot of work to show, but if you know your rules, finding these measures can be very quick. And part B says if AB is 2x plus 3, so that's this top side, and BC is x plus 7, they want you to find the length of CD. So in a rhombus, remember that all sides are congruent, which means I can set the two equations equal to each other. So 2x plus 3 equals x plus 7. We could go ahead and solve for x. So we'd get x plus 3 equals 7. Subtract 3, we get x equals 4. Now, they didn't say what x was. They wanted you to find the length of CD. So all you have to do is plug 4 back into either of those equations, since they're all going to be the same measure, and that should get you that CD is equal to 4 plus 7 is 11. So this is the answer they're looking for. Make sure you read specifically what they want, and then make sure you box in your answer. Okay, so similar with the square, same kind of rules. Okay, find what is congruent, set up your equations, and then you should be good to go. Now the harder problems, I would say, would be ones like this, where it says determine if the shape is a rhombus, rectangle, or a square, and list all that apply and explain. So there's multiple parts to this problem. Just for time, I've gone ahead and plotted these points for you and drawn the parallelogram, and you need to determine which of the three apply here. So the easiest way to do that when you compare a rhombus, a rectangle, and a square is to really look at the diagonals. So I'm going to go ahead and put that up here. Look at the diagonals, because In a rectangle, the diagonals would be congruent. In a rhombus, they are perpendicular, okay? And then obviously a square would be both. So if you can determine the length of the diagonals and the slopes of the diagonals, it's going to save you a lot of time determining which three. So if I want to find the length of the diagonals, I'm going to go ahead and draw those in here. We can use the distance formula, or we could use our Pythagorean theorem. I'm just going to go ahead and use the distance formula. So if I want to find the length of MK, I would use the 2 points here, M and K. So we're going to have 0 minus 2 squared plus 2 minus negative 2 squared. So we simplify, we get negative 2 squared plus 4 squared. This is going to reduce down to 4 plus 16, which is the square root of 20. Okay? Then we could do the same thing from J to L. So J and L would be these 2 points. So do the distance formula. So we'd get 5 minus negative 3 squared plus 2 minus negative 2 squared. This is going to get us 8 squared plus 4 squared. So obviously we're not going to get the same thing. We get 64 plus 16. Add those together, you get square root of 80. So they are different lengths, which means that it is not a rectangle, because in a rectangle they have to be the same. And the other thing too is we know that it can't be a square, because remember, a square has the same characteristics of a rectangle and a rhombus combined. So we know it can't be a square, but to confirm that it is a rhombus, we could check the slopes. So what is the slope of MK? Well, remember, we do slope is rise over run. So if I start at K and go up 1, 2, 3, 4, so up 4, and then over 1, 2, so left 2, that's a slope of negative 2 over 1. And if I do the slope of my other diagonal, JL, we go up 1, 2, 3, 4, so up 4, but then we go over 1, 2, 3, 4, 5, 6, 7, 8, so over 8. And if I reduce that, I get 1/2. So notice that my two slopes here, negative 2, 1, and 1/2, they are opposite reciprocals, which means that it is a rhombus. Okay, because our slopes are, or our diagonals are perpendicular. Now you could go through and calculate the lengths of all the sides. You could calculate the slopes of all the sides, but usually if you can look at your diagonals, that's going to save you a lot of time. So make sure you're very careful on what you're calculating. There's multiple ways to actually figure this out, so just make sure you show me your method and that you are clear with all your work, and then you should be good to go. Okay, so that's it for today. If you have any questions about the rules or how you set up equations for any of the 3 shapes in this section, let me know. But go ahead and do the practice problems and you should be good to go. Thanks for listening.